In this online lecture, we're going to go into molarity, which is our mathematical way of expressing concentration. There's other ways like percent solution and a few other things, but as parts per million and various things like that, we're not going to be using those mathematical treatments. We're just going to use this one called molarity. The reason why is that molarity is the most common way of expressing solution concentration. Second most common would be percent solution, but most of you understand percent a good bit. So we're going to be doing molarity in order to become familiar with it. When we say molarity, we often will replace that word with molar solution or with moles per liter. And the reason that we'll replace it with moles per liter is what molarity really means. Molarity is defined as the number of moles of a solute over the liters of solution. And we abbreviate it with this capital M. So capital M actually can be replaced with the units mole per liter. And remember, do not abbreviate mole anything other than MOL. But molarity, it really does mean moles per liter. So there's two types of problems you can do when you have molarity. One is the problem might ask to calculate molarity. It says, what is the molarity? And then from the values that are in the problem, you calculate molarity. But sometimes there's problems that give you a molarity. And in problems in which the molarity is given to you, what you want to do there is write your molarity as an equivalency and use it as a conversion factor. And so we'll go into this a little bit more. But when molarity is given to you, it's usually given to you as a number followed by M. And then after that is the name of the solute. And you can just take that capital M, remove it, and replace it with mole and then over liter. Because for that solution, 1 liter of solution will contain that many moles of the solute. Here is an example of a problem. It says, what volume of a 0.123 molar potassium permanganate solution contains 322 grams of the solute? Well, what's the solute? Potassium permanganate. Now, when I look at this problem, the first thing that I do is I say I can replace this solution concentration expression with different units. This capital M means mole over liter. So what I can do is express that concentration as moles over liter. And this is moles of the solute, potassium permanganate, over liters of the solution. You never want to start any math with a conversion factor. So you look, and the concentration of solution is basically a conversion factor. So you look for another measurement which you can start your problem with. So 322 grams of potassium permanganate is what you want to start your math with. So we start with 322 grams of potassium permanganate, and we realize we're going to try to go to volume, which is liter. So I have to go from gram to a unit that will then take me to liter. And since I have mole and liter as a conversion factor here, I know I'm going to have to go to mole. So I use the formula here to give me the number of grams in 1 mole. And that gives me 2.04 moles. I now can take that 2 moles and go from mole to liter using molarity as a conversion factor. So what have you learned from this example? First of all, when given a concentration of solution in molarity, take it and express it as a conversion factor, which you will use later. Then, the other thing that you've learned is look in your problem for the beginning of your math that is not molarity. 322 grams is. Think through your unit sequence, gram to watt, mole, then mole to watt, liter, and that then gives you volume that you need. So here's a problem for you to try. It says, what is the molarity of 6.73 grams of sodium carbonate in 250 milliliters of solution? Notice it's saying, what is the molarity? It is not giving you molarity. Here it's asking you for molarity. So what you're going to have to do is take the formula for molarity, which is molarity equals moles of your solute over liters of solution, and plug in the values into that equation to calculate your molarity. Pause and do the problem, and then press resume when you're finished. Okay, to do this problem, what you need to do is first write down the two things that are given to you. 6.73 grams, that's your solute. Your solution volume is 250 milliliters. Molarity is equal to moles of your solute over the liters of solution. So what I'm going to have to do is figure out how many moles of my solute I have. I'm not given moles in either of these, but I can see, and if you remember back to the chapter before, when given grams, we can figure out moles using the solute formula. So if I look at sodium carbonate, which is Na2CO3, I can calculate the number of grams per mole. And then I can use that to figure out how many moles I have. Then this will give me this number here. I now need to figure out how many liters of solution. I use my relationship between milliliters and liters, and that tells me that there's 0.25 liters. So now all I have to do is plug and chug. I take the solution. Molarity is equal to my moles of my solute over my liters of solution, and that ends up giving me 0.254 molar. Go ahead and try to do this problem. Notice molarity is given to you here. So what do you do with molarity is you change molarity into a conversion factor of moles per liter. Pause, do this problem, and then press resume when you finish doing the problem. Okay, what volume of 0.125 molar nitric acid is needed to provide 0.23 moles of nitric acid? This is my conversion factor, and so what I need to do is write it as a conversion factor, and that you replace a capital M with moles over liter, and this right here is my starting place. Why do I know it's my starting place? I never use molarity as the beginning of my math. I always look for another number in unit that can allow me to start my math. So I'm going to start with 0.123 moles. And then what I'm going to do is I'm going to go from mole to liter. Once I go from mole to liter, I look and it says, what volume? Does this give me a volume? Yes, it does give me a volume because it's going to be liters. And I know that that is my how I solve this problem, and I end up getting 1.8 liters. Here's another problem for you to try. Okay, in this problem, we see this is my molarity, so that's my conversion factor, and here's my volume of solution. So I'm going to start with 250 milliliters, and I'm going to use this as my conversion factor. Express this as the conversion factor first, then start my math with 250 milliliters. Now I'm going to go milliliter to what? Liter. Then I'm going to go liter to mole. Then I will go, since I need to have grams, and this only gets me to mole, I'm going to need to go from mole to gram. How did I get this value for grams? I use 1 hydrogen and 1 chloride. I take the molar masses of each of those, 35.45 for chlorine and 1 for hydrogen. It ends up giving me 36.45 grams. The solution of that is 0.091 grams.